Hi, everyone. Come join us for the next IoT show where we're going to talk about the embedded CSDK. I have two guests with us that are going to go over how to get started and get your hands on that public preview. So join Wellington, Eric, and myself soon. Hi, everyone. Welcome to the IoT show. Today, we are going to talk about the embedded CSDK. If you haven't heard, at Build, we announced the embedded CSDK is now in public preview, which I'm super excited about. And I have here two guests, which is great. I have Wellington. Wellington, did you want to give some background of what you do at Microsoft and what you're doing with this embedded CSDK?
So I'm Wellington Durais, and I am a PM in the IoT team. I am responsible for the CSDK and now for the new embedded CSDK.
Wonderful. And then as an extra treat, we have Eric on the team as well, who's joining us to talk about the embedded CSDK.
Hi, thanks. My name is Eric Wolz. I am the dev lead for the CSDK and now the new embedded CSDK as well.
Thanks, Eric, for being here. All right. So to get everyone knowing what the latest announcements was with Build, with the embedded CSDK, what is the embedded CSDK, Wellington?
Well, Pamela, you know that as the IoT industry evolves, companies and developers are out there creating and identifying more and more opportunities for amazing IoT solutions. But when we look at the devices that are enabling all of these digital transformation scenarios, we can find all sorts of devices going from pretty powerful hardware running full operating systems like something like a Raspberry Pi running Linux, but all the way down to single core MCUs, single core microcontrollers like this one, also known as constrained devices. Now, for these constrained devices, many of the things we take for granted might not be there. So you can think of electricity. We might not have an outlet close by the device. So we might need to think in terms, how can I power this device with batteries or solar powered scenarios? Also, when it comes to connectivity, so you can think Wi-Fi, it might not have Wi-Fi close by. So we might need to think in terms of leveraging cellular networks, mesh networks, LoRa, or things like that. So to enable scenarios with constrained devices like this, we completely redesigned our CSDK. And now we're happy to present the newest addition to the Azure SDK family, which is the public preview of the Azure SDK for Embedded C.
I am really excited because I've been working with the CSDK for the last couple of years, and I am really excited. What is this kind of new embedded CSDK and how it's different from the CSDK that we've been working with for a while now?
Yes, I do have a couple of slides to share a bit more about what are the differences and what's in it for the IoT developers. So let's take a look at the design philosophy behind it. There are 6 core tenets of the Azure SDK for Embedded C. So first and foremost is optimizing for size. As we're aware that our current CSDK is not a great fit for constrained devices. The second is to give customer choice to allow constrained scenarios where a specific library for, say, network might be needed. The third thing is no dynamic memory allocation. Then we're looking at fully embracing MQTT. We're also created this bring your own network stack concept. And finally, we like to consider this as our everywhere SDK, meaning that if your device can connect to a network, it's very likely that we'll be able to run the embedded CSDK.
That's great. And I'm glad even for the first optimizing for size, I think that was one of the biggest feedback, especially when I was coding with partners and customers, is with these really small constrained devices, and even with what people wouldn't consider a constrained device, but once they have everything else on the device and then bring a SDK on there, there was no room for the CSDK. So I'm super glad that the embedded CSDK has really focused on how can you improve that size and work with constrained devices.
Yes, absolutely.
So the people who are working with the CSDK now, is that still going to be supported? Can you elaborate a little bit more on, you talked about the differences, but a little bit more on the people who are using the CSDK, how is it different when it comes to the architecture for the embedded CSDK?
Absolutely. This is the embedded C SDK. So as you can see, here's a set of libraries that will help you take advantage of the Azure IoT capabilities. So here at the top, you have your application talking to the embedded C SDK and the MQTT, TLS, and socket layers. It is up to the IoT developer to pick and choose whichever MQTT client they want. So this could be Paho, Mosquito, or any custom library that they might have. Same goes to TLS and network. IoT developers have the freedom of choice to bring their own stacks, the one that is most optimized for the device they're targeting for their solution. So the IoT developers will leverage then the embedded C SDK for all of their Azure IoT interactions, like sending telemetry data, so D2C, cloud-to-device messages, device twin, direct methods, and device provisioning. Also, as we add new features to Azure IoT, the embedded C SDK will also evolve to provide IoT developers these features as well.
Nice. So for folks who, have been working with plug and play, is that going to be supported with the embedded C SDK?
It will be. It is not part of the public preview, but we are working to bring that functionality to the embedded C SDK as well.
Okay, and just for those people who are working with the C SDK and not been playing with the embedded C SDK, will they still be able to use the C SDK, and are we still long-term supporting that? Are we encouraging them to continue to the embedded C SDK instead? What is your guidance for those folks who already have devices in production that might be using the C SDK?
That's a great question. If you have a scenario in which you're using the existing C SDK and that's working for you, that's okay, that's fine. We will maintain support for that. And we're actually adding new features to the C SDK as well. So the embedded C SDK is not replacing the existing one. The new embedded C SDK is an addition to the family. So if your scenario would require a smaller footprint, I would say give the embedded C SDK a try.
Okay, wonderful. And then is there anything else you want to share, Wellington, before we jump into how to get started?
Yes. So enough of the theory. Let's take a look at how the embedded C SDK look like by exploring an example. So here, as you can see, so the sample we'll be showing is available in our GitHub repo. It is based on the x86 platform, and it can run on either Windows or Linux machines. Over the next couple of months, we'll be working with our Silicon partners to bring samples to their development kits so that developers out there will be able to see the embedded C SDK in action on real hardware. But as per the sample we'll be sharing now, this is a simple scenario that will send telemetry data. As you can see here on the screen, it will send telemetry data. And then as per the MQTT client here, we will have Paho. Remember, you can use any other client in your scenarios. And then TLS and socket will be provided by the operating system.
Are we going to give any examples on how to use all of those different components, just some getting started with the embedded C SDK?
Absolutely. That is part of the sample pages that we have in our GitHub repo. So yes. Okay,
perfect. All right. Well, maybe let's go ahead and start in there and look at the sample. So thank you, Wellington, for giving us an overview about the embedded C SDK. So Eric, definitely work your magic. I want to know how to get started. That way I can move from my working with my devices with the C SDK and then look into what's the difference with the embedded C SDK.
Hi, thanks a lot. we're going to walk through a couple things today. One of them, I'm going to walk through the edge and demo the GitHub repo. We're going to do an enlistment, and we're going to build the IoT samples, and then we're actually going to go through two samples, one for telemetry and one on device methods. So what I have up right now, so we're in a new GitHub repo. It's called Azure SDK for C, and all the Azure properties will be actually in this repo itself. If you go down there and you go to the SDK directory, there is a IoT directory which has all the IoT SDK in there. There's README files in here, so you can actually go and take a look at it. There's little snippets in here to get you going, but what we're going to demo today is actually going into the hub and the samples. So to enlist into the repo, I'll bring up my command prompt. And then I'll get the clone URL. And I'll just git clone it. And the SDK is very small now, so the cloning is very fast. All right.
That's what I want to hear, Eric.
Yep, and it's done. So we're done with the repo, and you can actually see it here. So the SCSDK uses CMake. So let's create our build directory. Go here. And then to generate the CMake files, we can just do CMake -d build, and we're going to use the PAHO MQTT stack. So and that will generate samples for us. Okay, that's once again very quick. So let's go into our IoT directory where our samples are. So go to source. So we're going to demo using certificate-based authentication. We have a sample bash script in here to generate our certificates using OpenSSL. Okay. Okay, so I have certificates created, and the thing you want to actually look at is our fingerprint ID. So I'll copy that over. And let's switch over to my hub, my IoT hub. So I already created an IoT hub for us. So let's go and create a device for our samples. And we'll create a new device. We'll call it IoT device. And we'll use a self-signed certificate. Obviously, in production, you'd want to use a CA-based certificate. And my device is actually provisioned now. So let's go back to our samples. And let's go to our CMake build. And we'll bring up the Visual Studio solution that has the samples in it.
Mm-hmm. But I can imagine you can use Visual Code.
You can use Visual Code.
VS Code and everything.
Yep. While that's loading, I'll bring up my Device Explorer and connect to my hub.
Mm-hmm.
Okay, so here's all the different samples. So the first sample we're going to use is actually a telemetry sample.
Mm-hmm.
I'll set that as my active project here. And what this will do is actually send 5 telemetry messages to my hub and then exit. So I'll start this, and we can go back to our Device Explorer, and we can actually view the telemetry that we're going to send to it. So you can see the 5 messages coming out, and here you can actually see 1, 2, 3, 4, 5. And those are all the telemetries that actually came in. We'll stop the monitoring here, and then we'll switch over to sending a method to the device.
Mm-hmm. So far, this is a lot quicker to get started with than our
that's it.
SDK.
Yeah. Yep. So now this is waiting for a method from the cloud to the device. So in my Device Explorer, I'll do direct methods, and I'll send a ping and invoke the method, and you'll see the response as Pong. And you also, in the command window, the device actually received the payload and responded with a Pong response to it. That's it. There's multiple samples for Hub. There's Cloud to the Device. There's twin examples, as well as we have samples for the DPS provisioning client in there as well.
And Wellington definitely mentioned that there's going to be some samples for dev boards. And
what? Oh, for dev boards, yes. So we are working on basically getting started walkthrough for the different dev boards from the SI partners as well. That's coming a little bit later.
Okay, perfect. Well, I'm looking forward to that. And I think the samples are really straightforward. As we could see, it was really quick to get started, which is really nice. I should have started a timer, but I didn't, Eric.
There's a timer at the lower end side of every corner of the screen.
Yeah, it's, if it was under 5 minutes, but I feel like that was definitely a breeze. So really appreciate you showing that. And also wanted to call out that we do have an upcoming deep dive video as well, where we will deep dive even further into some the examples, all of the different features of the embedded CSDK. So that's going to be live June 22nd. So mark your calendars. We'll have a link at the description. So I'm just doing a call out there. And then you'll also be able to get Q&A time with all of us on the video right now. So
that's correct. We'll look at the code behind the samples in the deep dive session.
Yes. So that should be really fun. Is there anything else, Eric, that you want to share with developers when they're getting started with this embedded CSDK? Just anything else you would like to share?
No, it's a much simplified version of the SDK. It's it's a lot more flexible. You can bring your own stacks, your own SSL, your own MQQT. So yeah, we're super excited about it.
Yeah, I'm excited too. So thank you, Wellington and Eric, for joining me and this IoT show to give an overview of the Embedded C SDK. I know a lot of embedded developers like myself. We're going to be super excited to get our hands on this and start playing with it. So thanks so much, and thank you everyone who's viewing. And we look forward to you joining us in our next IoT show.